Hello, so today we are talking about least squares regression lines. So this is textbook section 3.2, and least squares regression lines are actually something that you've seen in Algebra 1 and probably in Algebra 2 as well. Let's take a look at this graph. So is this regression line the best fit for this data? Well, what is the regression line? The regression line is this blue line that's going through some of the points, most of the points, around the points of my scatter plot. You may have heard regression line, also called line of best fit. In Algebra 1. So the line of best fit is just a line that goes through the data, but how do I know that it truly is the best fit for the data? How do I know that this blue line is better than a line, let's say, that looks like that, like that red line? How do I know that the blue line is better than the red line? They're super close, but they're not exactly the same. Well, how I know is by finding the sum of all the squared vertical distances from the data points. So the least squares regression line, or the line of best fit, makes all the vertical distances from each of the data points to the line as small as possible. So how we write a least squared regression line is y hat equals a plus bx. Well, this should look really similar to Algebra 1, y equals mx plus b, but this time it's a plus bx, so we're going to write the y-intercept first. Well, the slope, or b, is this formula, b equals r times sy over sx. This is a very common multiple choice question. It would give you these three pieces of information and it would say, what is the slope? Well, this formula is a super important formula. It's one of the main things we need to know about creating the least squared regression line. The other piece of information is that the least squared regression line always passes through the point x bar comma y bar. Meaning if I found the average of my x's and the average of my y's and plotted that point, my least squares regression line would go through that point. These two pieces of information, these two arrows, are more of AP exam kind of thinking and things that would show up there. So key point number 1, the least squared regression line is also called the line of best fit. It is used as a prediction model or a prediction line for a linear data set. So what does it predict? Well, it predicts how a response variable changes as an explanatory variable changes. So if we break down the equation a little bit, y hat is my prediction, so I'm predicting my y's, or my response variable, and I'm substituting in different x's, or different explanatory variables. So for least squared regression lines, a is my y-intercept, and b is going to be my slope. So that's a little bit different than Algebra 1. In Algebra 1, b was the y-intercept, and stats, a is going to be the y-intercept. So make sure you get this diagram down. So how we would see kind of the least squared regression line asked in a problem would be something like this. The table and scatter plot below show the relationship between student enrollment in thousands and total number of property crimes, burglary, and theft in 1 year for 8 colleges and universities in a certain U.S. state. So what I have is a table, and in that table it has the enrollment, so how many thousands of students, so this is 16,000 students, 2,000 students, 9,000, and then the number of crimes that happen per year on campus. So for the 16,000 person school, there were 201 crimes. For the 2,000 person school, there were only 6 crimes. It also plotted these points on a scatter plot over here and drew the least squared regression line. So it shows me what the line looks like, and I can see it's a good fit line. These distances from the point to the line are really small. So that's the vertical distance the definition was talking about. But if I want to find the equation, I need to find, well, what is A and B? Well, how I find that is by using my calculator. So pause this video and write down these 5 steps. What's in red is kind of the description of what the function you're doing is, and in blue are the actual, like, what you type into the calculator. So write down these 5 steps, what you're actually doing, and then how you do it, which is in blue. So let's go through this. We enter the data, or the X data, into L1 and the Y data into L2. This is very familiar. Step 3 is we want to calculate Y equals A plus BX. Well, how do I do that? So this number 3 is corresponding to this picture up here. So I press Stat, then use the left arrow over to Calc. Then I use option 8, which is linreg A plus BX. You'll see a picture of what the calculator should look like. You want this option right here. You don't want option 4. This is Algebra 1. This is Statistics. So once you choose option 8, your calculator is going to give you one of 2 screens. If you have a new calculator, it's going to look something like this. The X list you're going to type in as L1. The Y list is L2. Leave the frequency blank, so leave that blank, and then store it in Y1. Well, how do I find Y1? For Y1, press vars, use the left arrow over to Y vars, then press enter 2 times, and that's going to store your equation in Y1, which is super important when we start graphing these. So if you have an older version of a calculator, you're going to want to take a look at this bottom screen. So the older version, once you press enter on linreg A plus BX, this is the screen you're going to get. Well, you need to type in L1, comma, so those are commas, L2, comma, Y1. You find Y1 the same way, vars, over to Y vars, enter, enter. But you want to make it look like this. Also, the comma is above the 7 if you have trouble finding the comma on your calculator. So once you type this in or this in, depending on your calculator, press enter, and you're going to get A equals and B equals. Your calculator is going to give you what is A and what is B, or what is the y-intercept and what is the slope for your equation. So all you do is substitute those values in for A and B, rounding 2 decimal places. So if you follow those steps for this data set, this is the y hat equation that you will get. So take a minute, pause this video, and try those steps. Using this data, this is my x's, this is my y's. See if you match my y hat equation. So another question that you could be asked, it says, for a school that has 15,000 students, how many property crimes would you predict in a year? Well, if I think about using the equation we found in Part A, and knowing a school has 15,000 students, well, 15 would be one of my x's, and you can see I get pretty close to 15. I have 16 and 14. But if I want to substitute 15 in to see if I have 15,000, what's my y going to be, or what are the property crimes going to be? All I do is say y hat equals negative 112.58 plus 21.83 parentheses 15. Notice I'm doing 15, not 15,000, because the enrollment is already in thousands. When I press enter on my calculator, when I do that by hand, you get that y hat equals 214.87. Well, this is saying that if I have 15,000 students, I'm estimating that there's going to be 215 crimes. Now, before you jump to the next problem, just take a minute and look at this number compared to the numbers close to 15 in the problem. You can see that the numbers at 16 were 201, at 14 were 138, at 19 were 294. This number fits in nicely with this data set. It looks like it could be in this table. It's not too weird, so I can feel pretty confident that I got the right answer. So this is part B, and that brings us to the second key point. Using X values in your data range to predict Y values is called interpolation. So this is when I use X values in the range that I've seen before. That's an example of using 15 when I have data values ranging from 2 up to 25. This is a good prediction because I'm predicting within kind of the given range or within the given x-axis values. Well, what if I had something that looks like this? For part C, it says in 2014, the University of Texas A&M had 56,507 students. That's a lot of students at one university. So they had 56,507 students. Would you want to use your prediction line to estimate the number of crimes at Texas A&M? Well, if I think about 56,000, that would be 56 in this X range. Well, take a look at this range. Do I even get close to 56? No, my range goes from 2 to 26. 56 is super far outside my range. So if I'm asked to predict an X value that's really far from the given range of X's, we call that extrapolation. So using X values outside of the X values seen in your data range to predict Y values is called extrapolation. We do not want to extrapolate. This is a really bad prediction. So if you're ever asked to predict an X value way outside of your range, don't do it. It's a bad prediction. You don't want to do that in statistics. Why we don't want to do it is because we don't know what the data looks like beyond the given range of X's. If I know that this is my scatter plot and it goes like this, I don't know what happens with the X's way out here. It could maybe start to decrease, or it could curve up really big. Since we don't know what happens out here, I don't want to extrapolate. This is a bad prediction. So what else does my least squared regression line tell me? If I think about this line, we already identified the y-intercept and the slope as a and b, but I want to dig a little bit deeper into the slope real quick. The slope of a regression line is the predicted or average change in the response given a unit change in the explanatory. Think about slope before. In Algebra 1, you said slope was rise over run. Well, rise is the change in my y's, and the run is the change in my x's. That's the same thing we're doing here. The slope is the predicted or average change in the response, or the y's, given a change in the x's. So how are my y's going to change given my x's are changing by 1 unit? The y-intercept, or a, is interpreted as what would happen if x is 0. If x is 0, what could I predict for this equation or for that data set? So let's take one last look at another kind of element to this example. Part D says, interpret the slope in context of the problem. This is a very common AP exam question and a really common just question to make you interpret the data that's already given. Well, the slope is 21.83. If I think about my slope, or B, as my rise over my run, well, the rise would be 21.83 over 1 change in my x's. Or this is the increase in crime for every enrollment of 1,000 students. So I use my rise over run formula to say, well, this is the increase in my y's, or the increase in the number of crimes, given every 1x, or every 1,000 students added to a student body. If I had to write that in a sentence, or kind of in a phrase, I would say we predict an average increase of 21.83 property crimes for every increase of 1,000 students enrolled. So that's how I can interpret the slope using a rise over run format. And that's a wrap. We create least squared regression lines in order to predict outcomes and analyze a bivariate data set, so 2 quantitative variable data sets. Predicting outside the range of x's is called extrapolation, and we don't want to extrapolate. So this is section 3.2 in your textbook. Go there for extra examples and practice problems. Thanks, and I'll see you next time.